All right, so again, 10.3, we're going to be finding today all sides and all angle measures. So for prior knowledge here, we are going to have to be able to do this. We're going to have like two angles at some point, and then we're going to just basically subtract from 90 for the two angles adding up to 90. That gets you the missing angle. Okay? Yes? All right. So for skill development here now, we're going to be talking about angles. Notice angles, we always call them by a capital letter. We label them, I should say, with the capital letter, A, R, and T, or A, B, C, D, E, and so forth. Okay. That's should already be instilled in your brain. Anytime we have an angle measure, we call them by a capital letter. And then our new piece of information, which we haven't really done, is the side across from an angle. We name it with the lowercase letter of that angle. So like, for example, here I can see angle R. The side across from angle R, we're going to call it the lowercase r. Okay? And then a capital angle A, the side across from it, we're going to label it lowercase a. And then the capital T is my angle. So across the angle T, we have lowercase t for the side. Okay? And so if we look at the example, I forgot to block these out, but we're going to, that's okay if you see it, but we're going to practice here. Your paper should be blank, so that's okay. If we look at angle D is right here, that's a capital D. So across my capital D, we're going to label the side with the lowercase d. Okay, and then across my angle F, that's a capital F, so what should we call the side? Lowercase f. Good. And then here's my angle E, so across from the angle, capital E for the angle, so what should we label the side? Lowercase e, right? So practice labeling the sides with lowercase letters. Again, it's across the capital letter, it's going to be the lowercase letter for the sides. So if we look at the practice problem, go ahead and label the sides here for triangle Q, N, and Y. So again, remember, you always want to look for the capital letter. Across the capital letter is the lowercase letter. So let's go ahead and look now at our concept for today. Our concept says in order for us to solve a right triangle, that means we need to find the lengths of all its sides and the measures of all its angles. The key word here is all the sides and all the angles. So in order to solve a right triangle, you need to know two side lengths, or you can have one side length and acute angle measure. Then based on the given information, you have to choose between the different strategies. You can use regular trig ratios if you're looking for a side. You can look for an angle, so you have to use inverse trig, or you can use the Pythagorean theorem to help you find the side of a right triangle. The other thing you can know is the inside angles of a triangle is equal to 180. And then you want to use exact values whenever possible. Usually you want to use whatever was given to you because you're going to end up rounding at some point. And if you use a rounded answer to find another answer, your second answer might be wrong. Okay. So we have this picture here. And then it says, in order to solve a right triangle ABC, means we have to find the lengths of sides A, B, and C, and the measures of angles A's, B's, and capital C's. Okay? So, for example, I'm going to make up numbers. These numbers mean absolutely nothing because I'm making them up. Okay? Let's say my side A is 10 centimeters. So I know my side A is 10 centimeters. Then I need to know what's lowercase b, lowercase c. let's say my side B is like 12 centimeters. So I know side B is 12 centimeters. And then my C I get is 15 centimeters. Okay. Then I'm going to have to do some more math here. And I'm going to have to know what's measure of angle A, measure of angle B, and measure of angle C. Okay. Which one do I know for sure already? Of my three angles is what? Angle C is 90 degrees, right? And then let's say A ends up being 60 degrees. So if that's 60 degrees, what does B have to be? 30 degrees, right? So now I have all three sides and all three angles. So now my triangle is solved, okay? That's what we're going to have to do today. But obviously, we're going to have to do math to find the missing sides. I'm just an example here. I'm going to have to know what the three sides are and what the three angles are in order for me to solve the right triangle, okay? And again, those numbers mean absolutely nothing. I just made those numbers up. Okay, I see some of you guys are still writing this down. All right, just as a reminder here, we're going to use regular trig ratios for side lengths. And we use inverse trig to find an angle measure. And then this is still going to be using SOHCAHTOA. So you still have to remember the ratios for sine, cosine, and tangent. Sine is the opposite over the hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is the opposite over the adjacent side. But if we're looking for a side length, we use regular trig. And then if we're looking for an angle, we end up using inverse trig. So let's look at our very first example here. The directions say we need to solve the right triangle and then round the sides to the nearest tenth and angles to nearest degree. Okay, so if I look at my triangle, I don't have anything for these two angles. So I can't really use sine, cosine, and tangent yet to find this missing side right here. So my first thing I like to do is kind of go solve for like whatever we need to solve for. In this case, I need this side still. I don't know what that side is, but if I label it, what lowercase letter would that side be? B, right? I am looking for lowercase b. What can I use to solve for a missing side of a right triangle? Well, I can't use sine, cosine, and tangent yet to find a missing side. So we're going to end up having to use the Pythagorean theorem. So my Pythagorean theorem, remember, is a squared plus b squared is equal to c squared. Which side was my c? The 3.1 is always the hypotenuse. Always across the hypotenuse is the lowercase c in the Pythagorean theorem, okay? So I know that this one for sure has to be 3.1 squared. And then conveniently here we have the a and the b. So 2.7 ends up being side A, and then my b ends up being b. That's just because the sides were labeled A, B, and C. But they're not always going to be A, B, and C. They're going to be like P, Q, R. So you're going to have to figure out where to put the values in the Pythagorean theorem, okay? So in this case, I'm going to use 2.7 squared plus b squared for my Pythagorean theorem. Because I have decimals and I'm going to end up having to round, I don't want to do any rounding before my final answer. So instead, I'm going to just subtract over the 2.7 squared to both sides. So minus 2.7 squared to both sides. Those cancel. And we get b squared is 3.1 squared minus 2.7 squared. Do not subtract 3.1 minus 2.7 and then square that. No, you do on the calculator, type it exactly like that. You're going to grab your calculator, everybody. You're going to go 3.1 x squared on the calculator. Don't press equal. And then just go minus 2.7 x squared. And then press equal. That's going to give you your b squared value. So 3.1 x squared minus 2.7 x squared on your calculator. Were you guys able to get, I think it's like 2.32 maybe? Yeah. Okay. That's just my b squared though. I still need b. So now that I have b squared, how can I solve for b? Take the square root of both sides. That gives me my b is approximately. Here is where you want to round. Round to the nearest tenth at the very end. So on your calculator now you go second x squared, and then you go 2.32 equals. And whatever's in your calculator now, that's what you round to the nearest tenth. So what do you guys end up getting? 1.5. Good, thank you. And my units is centimeters. So now I have my three sides. I'm going to kind of put my answers to the side. I know my lowercase a was 2.7 centimeters. My lowercase b is what we just solved for, is 1.5 centimeters. And my lowercase c was given to me was 3.1 centimeters, right? The one that we solved for was b, so I'm going to highlight it. It's on the answer keys. You know how you have the answers at the bottom of your homeworks? You won't see 2.7 and 3.1, but you will see 1.5 because that's the one that you solved for, okay? All right, then I'm also going to have to figure out what's the measure of angle A, measure of angle B, and the measure of angle C. Which one do we know for sure right now? C is 90 degrees, right? And I know I'm going to have to solve for measure of angle A and measure of angle B. That's my two other things that I'm going to have to solve for, okay? Looking at my triangle, just pick a side. I'm going to use side A. Sorry, angle A. This is what I'm going to first solve for, angle A. Why? It doesn't matter. I'm just doing alphabetical order, okay? So angle A. Remember, now I can use sine, cosine, and tangent because I do have two sides to find a missing angle. So across the angle, is that the opposite, the adjacent, or the hypotenuse side? Opposite side. And across the 90 is which side? Hypotenuse. Across the 90 is always the hypotenuse. So is this going to be sine, cosine, or tangent? I have the O and the H. This is going to be sine. I know I'm going to use so because it's opposite over hypotenuse side. And my S stands for sine. So now I'm going to do the sine of angle A is going to equal my opposite side, 2.7, over the hypotenuse side, 3.1. And then what can we do to get rid of the sine? Take the inverse. Good. So we're going to find the measure of angle A by taking the sine inverse of each side. So measure of angle A. On the calculator, you're going to go second sine to get to the inverse. Second sine. And then you go 2.7 divided by 3.1. Close the parenthesis and press equal. So second sine 2.7 divided by 3.1, close parenthesis, press equals. And it's an angle. So for angles this time, round to nearest degree. So nearest whole number. What do you guys get for angle A? I hear 60 something. I kind of hear you guys mumbling. What is it? So 60.5 rounds it up to 61 degrees then? Okay. Measure of angle A then is 61 degrees. So now I know that this is 61 degrees. Now I can use the two angles have to add up to 90, right? Question?
So I'm confused with the first step. So we can't use
For this?
No, not that.
This one?
Yeah, when you're finding angle A.
Uh-huh.
We can't use adjacent.
Well,
We have all three.
we do, but remember we rounded this answer? So because this side is rounded, you don't want to use a rounded answer to find another answer because it might be off by a little bit. Okay? So you usually always want to use the two original sides that are given to you. Thank you for asking that question. You hardly ever want to use a rounded answer because you might have, like this one, we rounded up, right? So if you ever end up rounding up, that for sure don't want to use that because your next answer might be off by a little bit. In this case, because I'm looking for an angle, the angles are okay. They do have to add up to 180. So if we're saying 61 from that one, the other one has to, all three add up to 180. But I know that these two together have to add up to 90. So measure of angle B is going to be 90 degrees minus angle A, we found 61 degrees. So what's my measure of angle B going to be? 29 degrees. Okay. So then for your answers, like I said on the answer key on your homeworks, you're going to see the 1.5, the 61, and the 29. You won't see the other three because the other three were already given to you. Okay. Now my triangle is solved because I have all three sides and all three angles. That's what it means to solve a right triangle. Okay. All right, let's go ahead and do another one together now that we did this one. And hopefully it'll make a little more sense the second time around. Okay. For my next triangle, I have the side here is 8.8 inches and this one is 5.3 inches. So I'm going to put my 6 things on the side, the 6 things that I'm going to need. Because I have D and F, I'm going to need a lowercase d, a lowercase e, and a lowercase f. I'm going to need to know what's the measure of angle capital D, the measure of angle capital E, and the measure of angle capital F. What 3 things do we know already? 8.8 is which letter? Lowercase d. This is going to be 8.8 inches. I know that already because it's across capital D. That means this is lowercase d. What about 5.3? 5.3 is E. So lowercase e is 5.3. Which means we're missing this side. Which side is this one? Hypotenuse C, yes, and it's also going to be lowercase f. I don't know lowercase f yet. Alright, but again, we're going to use Pythagorean theorem to solve for f. So a squared plus b squared equals c squared. Which one am I missing? The c squared. Across the 90, remember, is always c. So I don't know c. That's really going to be my f squared right there. I don't know what f is. So then a and the b, it doesn't matter. So just go 8.8 squared plus 5.3 squared. Notice this time they're on the same side, so we don't subtract. You're just going to type it in like this on your calculator. On your calculator, do 8.8x squared plus 5.3x squared. You should get 100 and something. I forget what it is. 105.53. Thank you. And again, you don't want to round until the very end. Just leave that 0.53 right there for your f squared. And then to solve for f, you take the square root of each side. So f here is where you round. So take now on the calculator, second x squared, 105.53. So second x squared, 105.53. And what do you guys get for your answer? 10.27, but we got to round to the 10th, so 10.3. Because it's nearest 10th. So 10.3 inches. That's the side we solved for. So I'm going to highlight that one because we didn't have f. We found f. So on the answer keys, you would cross out like 10.3 in your answer. Okay, and then for my angles, which one do we know for the angles? Thank you. F? Yes, angle F is what? 90 degrees. Good. All right, then we're gonna use SOHCAHTOA for the other one. Do you guys care what do you want to solve for first, D or E? D? Okay, so if we do D, across D, what side is that? Opposite side. And 5.3 ends up being which side? Adjacent side. Notice I'm not looking at side F because I did not know what F was originally. I have an O and I have an A. So what trig function is that? Tangent. We have TOA. Right, so I have the tangent of angle D is going to equal opposite is 8.8 over adjacent is 5.3. And then how do we get rid of the tangent? Inverse. So measure of angle D is the tangent inverse of 8.8 over 5.3. So calculator, please, you're going to do second tangent. (8.8) divided by 5.3. Okay, and this time is an angle, so nearest degree. What did you guys get for your answer? 59? 59 degrees for angle D. And again, we found that this was 59 degrees, so I'm going to highlight it because we didn't have that one. And then what do we do to solve for angle E? Subtract from 90. Measure of angle E. We're going to just do 90 minus 59. And what is that? 31 degrees for angle E. And that is my third answer that we just solved for. So my three answers that were missing was the lowercase f, 10.3 inches. Angle D was 59 degrees, and angle E is 31 degrees. Now my triangle is solved because I have all three sides and all three angles.